Is the era of manual bug fixing ending? Well, Google seems to think so. They've just released Jules, an AI agent that works autonomously inside your codebase. But does it actually work? In this video, we're not just going to talk about it, we're going to demonstrate it. We'll assign Jules a task and show you the entire workflow from start to finish. I have a pretty complex multiplayer game that I've been working on, and I'm going to use Jules to help me debug some of the problems. So let's get started. Okay, so the very first thing is if you go to Jules, JULES.google.com, you'll get a screen that says sign up for Jules or request to be part of the beta most of the time. So I did that, and now it says you've got access to Jules asynchronous coding agent. Try it now at jules.google.com. So we'll click on that. You're going to see a privacy notice that looks like this. And you can check or uncheck these boxes to receive emails, updates. I usually leave them. I'll ignore them if I don't want it. Now, we can see here we've got jules.google.com. It says it's an async development agent. So that means this thing can go out and do stuff while you're not around. That's the whole idea here, right? So Jules tackles bugs, small feature requests, and other software engineering tasks with direct export to GitHub. So I'm going to connect to GitHub here. And as you can see, it says sign in to GitHub. We'll click sign in. I'll send an SMS here. Always use two-factor authentication, right? Okay, and then it's going to say here, Google Labs Jules by Google Labs Code would like permission to verify your GitHub identity, which it's doing right now, know which resources you can access, and act on your behalf. Now, this is something that's important to look at. Don't just skip through this. Know that Jules can act on your behalf. That means it can create repositories, destroy repositories, commit code, break your stuff, who knows? So just something to keep in mind. So we're going to authorize this. Now it says, where do you want to install it? Well, there's a few different things I have here. So I'm going to say only select repositories. Now, I have this game called Retro Racer that I started out with some vibe coding and have since started really putting things into it, trying to get it together, make it multiplayer. It has some problems, so I'm going to select that one. And this is called Retro Racer. And then I'm going to say install and authorize. Now, one of the cool things is it says we're authenticated with GitHub. One of the cool things about Jules is, from what I've read, it creates a virtual machine that builds and runs your application. Now, this is a Node.js application, and it has a Golang backend. So this is, I think, a really good test for this to see how well it puts together a virtual machine with two different things, right? We have to have Node and Go installed. We have to build the Node package, run it and serve it. Then we have to build the Go package, etc. So it says, right, ask Jules to work on a task. Okay, well, one of the things that I have with this is, and I'll clone this onto my local machine. One of the problems I'm having right now is getting it to work with multiplayer. So maybe Jules can help me make the multiplayer stuff work. Now first, let me show you how Retro Racer works and how we need to set it up for development. Now it is a Node application at its core. In here, in the backend folder, I have a Go application that will handle all of the multiplayer stuff. So here I'll do npm run dev. And this will start up my Vite server, and then we'll have that web interface. And then I'll start up another server here. And I'll go into the backend folder. I'll say go run main.go, and that will fire up the backend server. Okay, and I've got the video game started up here. Now, if I type in single player, everything plays good. Sweet. And we don't really have many problems with this, other than you can see that my enemy cars have a little bit of trouble. right? So what we'll do here is refresh it. Now I go into multiplayer, and in here I type in my name. I say join race. Cool. Looks like I'm here. I'll start up another browser session. Now I have this session here, right? And we're over here kind of by the start line. Now I'm going to take this other session, and when I go to multiplayer, I should see myself as an active player, but it says disconnected. So I'm going to put in Jeremy2, join the race. And as you can see, I don't see my other player here. So the multiplayer isn't truly working the way it should. And that's what we're going to try to fix. Okay, so now I'm back in the Jules interface here, and you'll notice that I have my Retro Racer repository here and a main branch. Now, one of the things that you should always do is create fix branches, feature branches, things like that, so you can make a bunch of changes and then commit them back later. This is always a good practice. So what I'm going to do is create a new branch for this. This is especially important with AI coding tools because they can take your code and do all kinds of wild stuff with it. So you want to make sure that you can roll that back or commit it if you like it. Okay, so I've created a new branch, and so I'll refresh this. And now we can see that we have the Fix Multiplayer Sessions branch. So I will select that. And now we're going to ask Jules to work on a task. Now we're going to use some basic prompt engineering here. We want to be very detailed, very thoughtful, and specify exactly what we would like it to do. So one thing I will do here, and you'll notice here that when you're using Jules, I have a daily task limit of 60. It's pretty easy to eat that up. So you have to be very careful and very intentional with your quotes and requests and things like that. So I'm going to say, examine my multiplayer game. It is a Node.js game with a Go backend to help with multiplayer connections. Now, the first thing I want to do is I want to make a statement right up front. I want to say, I want this to be a multiplayer game where players can play against each other. So, just to put it simple, I want to make this a multiplayer game. I want there to be a session that starts when the Go application, or I should say, when the Go backend application starts. This session is a game. Every client that connects through the browser will join this game that is already in progress. When clients join or leave through the application, the game keeps running until the executable stops. So here I'm using very plain English. I'm not being very technical at all. I'm saying, examine my multiplayer game. It's a Node.js game with a Go backend. That's about as technical as we get, which is not at all. And I'm saying, I want to make this a multiplayer game. I want there to be a session that starts when the Go backend application starts. The session is a game. Every client that connects through the browser will join this game that is already in progress. When clients join or leave through the application, the game keeps running until the executable stops. Right now, this functionality isn't working. And one of the things we could do is we could drop in some console logs, right? So we have this thing, and I forgot I shut it down here, so I'll go back in. And I was creating that branch, so we're going to do npm run dev. I'm going to go to this application, go run main.go, and then we will jump back in to our game. We're going to open Developer Tools, and I'm going to clear the console history, clear the console completely, select multiplayer, type in Jeremy, and then join race. Connected the server successfully, etc. We've got all of this stuff. So I'm going to, of course, copy this. And we'll give it that first bit here. So I'm going to say copy console. And that's going to be the first part that I put into Jules here. Here is the console output when I join the game. And at the bottom we could say please or whatever. It's one of those things that we do by habit, right? We start to think of the AI as a person, but you can say fix this game so that multiple people can play against each other at once. Command enter or push the button, say give me a plan. And as you can see, it's booting up the VM. So this is an important thing to take note of. What makes this different from GitHub Copilot or Cursor or Windsurf or any of the other ones out there, any of the other tools? Well, the biggest difference is that Jules will actually take my code and it's going to pull down my repo. It's going to pull down the branch, which I think I selected back there. It's going to pull that down. It's going to start up a virtual machine, build it, run it, and then look at the output. So as this is going, I sent a console log in there just to kind of get things started. But as it runs the game on that VM, it's going to check all the output and it's going to check whether the game's running, check executables, things like that. So that's where the difference is. This is actually taking my application, building it, running it, and then suggesting some changes to make. So while this thing is going, we'll just kind of hang out, grab yourself a beverage. Ice water is always my favorite, and come back to it because sometimes this can take a little bit. Okay, and it's come back with a plan. Let's take a good deep look at this plan. It says I've created a plan to address the multiplayer issue. Notice it doesn't say I've fixed it. It says I've created a plan. Please review it. Let me know if you have any feedback. Otherwise, let me know and I'll get started on the fix. Okay. So here, it's going to refactor server-side player joining logic, modify backend server multiplayer.go. It's got a whole bunch of details here. Ensure the joining client's player name is set, etc. It's going to go through and do a bunch of stuff with my Go application. Then verify client-side handling through connectionmanager.js. Now, this is something that I've spent hours of time in this file, so I know that it's looking in the right place. And it says, ensure that join response handler is sufficient for the client to receive the complete list of players, including itself, initialize or update its local connected players array, etc. Then it's going to do some testing. After changes, we're going to test a scenario. Now, here again is where Jules is going to be an agent. It's going to be different from Windsurf, Cursor, and the other ones because it's actually going to try to run this program and it's going to try to do some tests. It's going to do client 1 joins, client 2 joins, client 2 should see client 1, and client 1 should receive an update about including client 2. Verify console logs on both client and server to ensure that player lists are accurate at each step. Then it's going to submit the change with a commit describing the fix for multiplayer join logic. Approve plan. Notice it says plan auto approves in 6 seconds, but I'm going to go ahead and approve the plan. Now it says plan approved, working on, and it's going to start churning. This can sometimes take 20 minutes to a half hour to probably longer for more stuff. So again, grab that ice water, go take a walk in your driveway or something, and let this agent do its job and try to come up with a proposed solution for our problem. Okay, so now it's come back and it's instantly showing me some diffs that we can go through here. And it says Jules waiting for your input to continue working. So let's take a look at this. It says refactor. This is our plan that we've already seen. Now it says it's refactored the server-side player joining logic and backend server multiplayer Go to ensure accurate player lists are sent upon join and removed premature game start messages. Okay, so it updated the Go one. Verify that Connection Manager JS is expected to correctly handle the server's updated message flow, primarily relying on join response for initial player and game state. Awesome. Could you please test the game now by having multiple clients join? Focus on whether players can see each other and if the player counts are correct when the new players join. Okay. And you can see here, these are all the changes that have been made. We can download them, etc. Let's go back into Visual Studio Code. We're going to go here. We're going to stop the Node app. We're going to stop the Go app. Now let's go back here, and I can just copy all of this to the clipboard. And we know that this is multiplayer.go. So I can go into my backend. Multiplayer.go. And just dump it in that way. So in here, I'll do npm run dev. And I'll go back here and go run main.go. And as we can see, server multiplayer go 157.7 declared and not used PID. So let's scroll down to take a look at that. 157 for PID. And we can fix this with one of our AI tools, but I would like to have a little conversation here to see why that is, why PID is not used anymore. So we might get a better explanation from this. And in here, you can just dump in the errors like this. So I can say go 157.7 declared not used PID. And of course, we can see in here, we can check the diffs while this thing is working on testing and making things happen. It looks like it removed a bunch of stuff here. So it possibly removed too much, which is something that can frequently happen with AI-powered coding tools. As you can see here, it says working on, and it's doing the tests. So it's running the tests. So it should find the same exact error that I just found. The loop is currently for PIDP client. Modify this loop to use the blank identifier for the map key for client that way, right? So we can just replace that with a blank key. And now it looks like Jules is going to do the same thing, which we can do that. And it looks like ours is running now. So we'll go here to Node, Go, everything looks great. Let's open up our retro eraser. We'll restart it. We'll do multiplayer. We'll do Jeremy, join race. And I can see there's another Jeremy there, and I'm not sure why that is. Possibly because I have another client joined, right? And it doesn't look like it. So in here, I'm going to put Bob, join the race. And I can see Jeremy sitting there. So I'll jump over to this one. And Dave. And now I can see Jeremy and Bob. So I'm not sure where the Jeremy player is coming from, unless it's just not killing them in time. And maybe it's not removing the player. So as I'm sitting here, interestingly, they're both stuck in the same place. So our multiplayer stuff isn't quite working because this player here should be visible And when one moves, should see it on the other screen, and we do not. So it's close, but it's not quite there. So as you can see here, they're just showing parked cars around. So it's close, but it's not quite there yet. Now I'm going to refresh this. That should make me go away. Type multiplayer again. Put in Peter. Join the race. Now we've got Peter in here. So we've just got a stack of cars kind of all in the same spot. And this is helpful for describing to Jules what we need to do. Now, full disclosure, this demo may not work, as in Jules may not fix my very complicated multiplayer game here. But what I really wanted to show is the workflow and how it works, how you can go through it. And here we can look, I fixed the unused variable. Could you please recompile and test the game again? Now it says, please verify that client 1 joins. Client 2 joins. Client 2 should see client 1. Client 1 should receive an update. Player counts and the client logs are correct. No new console errors in that. So what I'm going to say is, yes, the client joins. And I'm going to describe my problem here very carefully. Yes, actually I'll say, yes, client 1 joins. Client 2 joins and can see client 1. However, client 1 remains in a parked position in client 2's view, even if client 1 moves. So the clients can see each other, but they are not getting the proper updates. Players are not being removed from the game when I close the browser window or refresh. Now, this is going to, again, come up with a plan. Right? So it's going to take everything I said, it's going to make a big plan, and say, hey, how does this work? Now, if we look here, it's being very verbose about what it's doing. It's saying, review how player position updates, type update from client, are received by handle multiplayer message. Ensure that these updates correctly modify the player's state on the server, which is their position, their rotation, their speed, etc. Verify sync player positions, etc. So it's giving me a very detailed view of what it's trying to do with my code base. Okay, now let's come back here, and it's made a few changes, it looks like, to several of these. And we've got some messages. It says it's waiting for my input. Seems like I'm having trouble modifying Connection Manager.js directly due to environment limitations. I'll try to change the server-side code. So it updated multiplayer.go, updated backend server.go, and hub.go. And it says I've made significant changes to address. There's a whole list of here of things that it is trying to address. So I'm going to go here to client.go. I'm just going to download this into my projects, in my repo. Games, Retro Racer, backend, and client.go, I believe, is in server. There we go, client.go. Yes, I would like to replace it. Hub.go. I'm going to download that. Yes, I'd like to replace it. And multiplayer.go. And yes, I'd like to replace it. I'm going to go back here to VS Code. And you go run main.go. Seems to be running. I'm going to restart npm here, or restart Vite, and then let's see how our server works. Now, here's one client here. We can just start with this one and refresh. We want to do multiplayer. We're going to do Bob. Join the race. Okay, Bob's sitting here chilling out. Let's jump into the other one. Restart multiplayer. Active players still showing disconnected. So I'm going to do Dave. And I can't see Bob. And Bob can't see Dave. Right, we're just kind of stuck in the same spot that we were to start with. So these fixes didn't work. However, I did want to show the workflow for this. As we go back, and it says, let me know your findings. This will help determine if issues are resolved or further adjustments are needed. So here I can say this did not work. And we can go on from there. The clients cannot see each other. Now, what's important about this is that you've got a good track here. You've got a good history showing what you've done. We're doing all this stuff in a branch. If the branch doesn't work, we can delete it. If it does work and we can get it working, then we can merge it into our main branch. So this stuff is pretty cool. Now, Jules will make commits for you if you have it set up right. So we have our things here. You can see the tasks that are running. So completed or dormant tasks will show up here. And you can see here, coming soon, we're bringing more capacity online to get more people, more code casts. Okay, I don't know what a code cast is, but yeah, so I just wanted to show how this works, how it's set up. You can see here, daily task limit, we're still working on that first task. And we can see needs clarification. I'm sorry, the clients still can't see each other. This is unexpected after the recent changes. To help me diagnose this, could you please provide the server logs and the JavaScript console logs from both client 1 and 2 in the process? So we can go through and do this and continue to try to make this work. But for today, I just kind of wanted to show how this works, how everything is set up, and it really is a pretty cool little project. And you can do a new task here, and I can say, hey, let's work on something new here to do on this task. So that pretty much wraps up Jules beta. It was just released. It might change. It so far seems to be pretty good. I've used this on a couple of things. My multiplayer game was the most complicated thing that I could find right now for Jules to look at. I did that intentionally. If this were just like a Python snake game, I think it would just really quickly wrap it up and fix the problem. You know, if it's something that could be fixed by Copilot or whatever. But I thought my really complex game would be a good challenge, and it was. Maybe Jules will make it work, maybe it won't. But this is how it's set up, and it's pretty cool. There's also a video here of how it works that shows you kind of how Jules works, how it's set up. It's really cool stuff. Thank you for watching. Unlike code completion tools you might be used to, Jules is designed to be an autonomous developer that can take on entire tasks on its own. It's like having a junior developer that you can just give them tasks and they come back with answers. And you've seen that in this demo. Here are some key parts of Jules that we covered. It attaches to a repository. Now, this means that you need to put all your code into a repository, but that's not a big deal. It's an agent that makes a bunch of changes at a time, so clear descriptive prompts are very important. Now, what sets Jules apart is it creates a virtual machine, executes your code, and checks the outputs logs, and running services. This is a lot different from the AI code completion tools that we're used to. This is actually building and running your project. Now, it thinks about the problem, shows you the plan to fix it, and executes the plan. Now, you're limited to how many tasks per day that you can do, but everything we did today was considered one task. You can download files or make changes manually, and at the end of the task, you can have Jules commit your code back to your repository. I hope this has helped show you what Jules is all about. If you have any questions, leave them in the comments, or join us at the Code Cloud Discord server. Let's talk about it. If you like content like this, subscribe to our channel. Thank you for watching.